Feel free to test. Test 2. Is that not working? Huh. Test 1, 2. One, two, three. No. Test 1, 2. There you go. Test 1, 2.
Okay, I'm seeing audio.
1, 2, 3.
Good morning. We have audio.
How's this? Test 1. Test 1, 2. Test 1, 2. 1, 2, test. Test 1, 2. That is better. Okay. We'll try that. Test 1, 2. There we go. Okay. Hey, everyone, welcome out tonight. Is this too loud, too soft in the back? Good? Okay, let me switch this over. All right. Cool. So, we're excited you're all here tonight. Got JavaScript design patterns. I'm doing that one. I'm the lucky one there to get to present. And then after that, Danny Fenstermaker is going to present on Angular and Google Analytics. Thank you. I just had this total mind blank. That's what happens, I guess, when you prepare a presentation and have to run it at the same time. So, a couple quick announcements. Adobe likes us to remind everyone where the restrooms are. So if you'll go down, straight down the hall, instead of turning right toward the entrance, you'll just keep going straight past the computers on the left, past the fireplace, and take a left. And down that hallway is where the bathrooms are. So other things, I think that's, oh, I'm supposed to announce there's another meetup. Trying to remember okay, help me out. Mobile development using AngularJS use what? Ionic. So there's an Ionic meetup. I'm supposed to announce. Everyone who wants to do Ionic, go take a look. A lot of cool stuff going on. I don't know, meetup.com. But it's a local meetup. The guys running it are pretty cool. So, all right. So without further ado, we'll get into Yo Mama's Got JavaScript Design Patterns. So quickly on me, I don't need to in this forum, but senior software engineer, been working for 10 years, doing development, full stack. Last 2 years, I've focused mainly on front-end development. And most importantly, for me, I'm a family man. I've got 4 kids, and I love them to death. They are awesome. I work for a little company called Client Success, and I have to plug them. We're looking for senior devs right now, and we do some fun development in AngularJS, a little bit of React. Backend, we do Node and Clojure, and we have some Java services, but if you come, you won't have to work on those. Clojure and Node are the cool things for us for backend right now. So if any of that interests you, come talk to me afterwards. Love to get your info and talk with you. And as part of that, I have to do this at the beginning. I have 2 t-shirts to give away. I've got a men's, I think it's extra large, and a women's large. So, oh, how do we do this? Who's most excited about being here tonight? Yeah! Is that it? Come on, who's excited about being here tonight? I'm excited to hear Danny's talk tonight. Everyone clap. Woo! All right, so that was the loudest table. And I've got the women's tea right here. I got 1, 2, 3, 4, 5. I have no idea how to make this fair. I'm sorry. I'll have to do a random thing afterward, okay? That's what we'll do. Let's do that. Okay, you are in charge of writing a JavaScript random function to assign names. There are 5 women in the room going from this side to this side. So 1, 2, 3, 4, 5. Just do a rand with 5, okay? Dude, phones are computers now, right? All right, I'm getting distracted here, but I have to do this real quick. Random.org is a true random number service. You get that? True random, max 0, yep, max of 5. Generate results number 4, which is right here in the pink shirt. All right. Thanks for that little segue there. Okay, talking about design patterns. Who here is familiar with design patterns? So we've got only a few hands. There's like 6 or 7. That's great. This is mostly beginner talk. I find focusing on the fundamentals really helps my code, so it's really great for anyone. Who's heard the term design patterns? All right, who knows what the Mediator pattern is? A couple of those others. Okay, cool. We're going to talk about that tonight. So design patterns, we're going to go through these 4 things: history, and how they work in JavaScript, and then building large-scale apps using just 3 design patterns that we're going to talk about tonight. So, history. This term patterns actually comes from architecture. There was a guy named, I can't remember his name. I don't have my notes. He was an Austrian architect. Oh, he's an American architect born in Austria. There we go. Christopher Alexander back in 1977, so not that long ago. But he wrote a big book about patterns of how to lay out roads and cities to make it the most beneficial to residents who would live there, residents and businesses and all of that. And he coined this term patterns in that regard. So patterns, after that, he talked about how patterns would help us communicate, save time, and then I like to think of patterns as helping us to abstract ideas away, because the human mind's can only focus on 1 or 2 things at a time before it gets sidetracked. So we're going to talk about those. So patterns help us communicate. If I show you this picture, there's a bunch of different roof types there. Each of those has a name going along with this pattern book that this guy described. He also did not just cities, but buildings. And so you can see on the bottom middle, there's this shed roof. Just above that, there's this gambrel roof that's like a barn. Each of those is used for different things. But if I come wanting to build a house, as Johnny Appleseed, and I say, hey, I want a roof with a top line that follows the full length of the house, and it should be in the center of the house, and then the sides of the roof should come down equally on each side and angle out toward the center, an architect would just come back and say, oh, you want a gable roof. It's going down a little each time. Not gable. That was gambrel. Excuse me. I don't know architecture design patterns, just, computer ones. So they save us time because an architect can just say, you want a gable roof, and you're good to go. But someone out here is going to say to themselves, I don't want to follow these patterns. I like doing my own code. I like building my own thing. I want to design my own roof. Well, that's totally fine, but you should really think about what you're doing before you go and design your own roof. Because if you don't think about it, you might end up with something like this. This doesn't follow any of those patterns directly, but think about what the purpose is behind this roof. Was his purpose just to follow a standard design? No, he's trying to create art that inspires people. So there is actually a purpose sometimes to moving away from patterns. You just have to be sure to think about it a lot first. So the last thing here is patterns help us abstract ideas and think broader. If we talk about one of those patterns that we saw before, we can take this shed roof pattern, and in communication with one of our friends, we could say, well, what if we start, saying I'm an architect here, what if we start with 5 or 6 shed roofs, and then we warp them a little bit, put them on varying planes so they kind of intersperse with each other to make it a little more interesting. Well, suddenly, we've just built this. All this is 5 or 6 shed roofs all put together and then warped. So being able to use that term, shed roof, actually helps us be able to quickly get down to what we're trying to figure out and communicate clearly with people. Here's another example. This is Miller Park in Milwaukee. Miller Park it's the only fan-shaped roof, at least at the time I found this article. It was the only fan-shaped roof that can open and close in less than 10 minutes. So it opens all the way, so it's bright out when it's bright outside, and then it closes when it's not. And this is just a bunch of big gambrel roofs put together. If you look here, you can see the curvature underneath. Now, of course, there's more to it than that, but the basics, when the architect first thought of this idea, he could say, let's just have gambrel roofs that move into each other. So that's one of the other purposes, is to start with one idea and have a common vernacular between each other and be able to expand on that and expand other ideas. All right, so what? Who cares about all this real architecture, right? Let's get back to some devs. So software patterns. Has anyone heard, oh, not yet. Has anyone heard this quote? The secret to building large apps is never build large apps. Anyone heard that? This is something I live by. If you build a large app, you have a large app to maintain. If you build a bunch of small apps, then it's a whole lot easier to think about and reason about those applications that you're building. And as it says, break your applications into small pieces, then assemble those testable, bite-sized pieces into your big application. Justin Myers, one person who said this. I've heard it from many others. I don't know who the original quote was. It's been around a long time. So let's talk about patterns. This is the first book that talked about patterns. It's a Gang of Four. Anyone heard of this book, Gang of Four Design Patterns? Got a lot of hands on that one. These four computer scientists broke up computational design patterns into three basic groups, these creational, structural, and behavioral. And this is a list of all of those. And we're going to dive into each and every one of those tonight. No, we're not. There's a lot there, and we're not going to even start. Some of these apply differently to different programming languages, so I'm going to bold some of these. These are some that are important, particularly for JavaScript. You can see there on the left, prototype, singleton. You may not, you know what prototype is. You may not know what singleton is, but every time you use Angular to dependency inject something in the top of that, you've got a singleton that's being passed in. And there's a bunch of others here. Now, there are other types of design patterns as well. There's architectural patterns, which are on a broader scale. So some of you have heard of MVVM, MVC, yeah? Or what's the new one? I can't remember it. I don't know that one yet. There's MV star, which is just anything that's MVP, MVVM, MVC. Flux for React, also used with Redux. And N-tier architecture, so a module pattern, rebuilding module pattern. These are all some things that we do. You might be saying to yourself, wait a minute, what's going on? I thought this was an intro to design patterns talk, right? It is. Okay, we're going to focus on three patterns tonight: the module pattern, the facade pattern, and the mediator pattern, and go through those. And once we have those three patterns, we'll get to number 4 and build a large-scale app with those simple patterns. All right, so the module pattern. This is a bunch of text. Next. All right, module pattern. The problem with, so the thing with design patterns is what we like to do is present a problem statement that we're trying to solve, and then what our pattern does to solve that. This is how that Gang of Four book works and a lot of the other books. I'll give you references to a lot of books at the end that you can jump to, and some fantastic free resources that you can dig into this deeper on your own. So, the module pattern. JavaScript didn't, I need to update that, didn't have built-in modules. Who's on ES6 in here? Good few. So ES6 does have built-in modules, and you've got the import statement right at the top. Who does any node development in here? That's a lot more. So Node has built-in module pattern using common JS, where you have the you export your module at the bottom. So those are modules. So you're already familiar with what these are. I'm going to show you an example of a vanilla JavaScript ES5, so without the export functionality of a module pattern. And you might recognize this a bit. So this is a module. At the top here, you can see we have this immediately invoked function, and that's so that we can create a closure around everything in here. By default, if you've just created an object and thrown it out there, it's in the global namespace. This is how we get into different namespaces in JavaScript, by doing an immediately invoked function to create our closure. So anyway, that's the top. Right here, we've got some private functions that cannot be accessed outside of this, and then we have our public functions. This is a common pattern that's used in a lot of the frameworks that we use. There's also a little bit different to this, something called the revealing module pattern, which says, hey, I'm going to take my functions that are at the bottom in this return statement and move them right up here. And do that again. So they're just in the bottom of the return statement. and I'm moving it up to the top. You can see, let's see if I've got this. All right. No, got to do this side. All right, you can see we've still got the private variables up here, my private method, and I've got this public function right here. But it's only public because what this namespace, my namespace, returns is public variables. So there's my public var foo and my public function that's actually just returning a reference to that function. So this is a common pattern that's, that Adios Mani talks about in his design patterns book. A lot of other JavaScript pattern writers talk about this pattern as well. So the thing about module patterns that's so good is that it helps us to separate our code and really encapsulate what we're trying to do. So encapsulate just means I want to keep everything that deals with this type of function in the same place. So if I'm writing a dog object, everything that deals with dog should be in my dog object, unless it's shared with a mammal object that the dog extends from. Some of the disadvantages of this are prototype methods can't be patched, and that's usually not a problem in JavaScript. So as I talked about before, there are a couple of implementations already. CommonJS ES6 has it, and AMD is an old one that's great as well. All right, any questions on the module revealing module pattern? Is that too fast, too slow? Is that all right? Good? Okay, all right. Facade pattern. So when we put up a facade, we present an outward appearance to the world that may conceal a very different reality. It's just like those Old West towns where you've got a one-story building and a three-story front on the building to make it look like a big saloon so everybody wants to go there. Same thing here. Well, not quite the same thing. But what we want to do here is we want to create a facade, a wrapper around something so that it is easier to work with. So if we take this example in the JavaScript right here, this add event, this would be an example of jQuery, adding an event, adding an event listener. So there are multiple implementations of adding event listeners, whether you're working in Internet Explorer or Firefox or what's the new one? Brave? Anyone downloaded that yet? No, Brave browser or Chrome. And so these are some of the implementations, but we don't want to have to deal with that every time we write an add event listener. We want to have that all in one place, abstracted away so we don't have to worry about it. So that's what this add event does. It's a facade over multiple implementations of the same thing. So here are the multiple implementations, and we consolidate it into a single method. So some libraries and APIs have very complex interfaces, namely Internet Explorer and Safari. They're different how they work. And so if you want to do something the same across them, you create a facade. And that's an easy way to do that. Other things that might happen, if you have a library that you want to use for interacting, say you want to interact with Gmail, and you want to interact with an IMAP service. Both of those are going to have different interfaces for interacting with them, and you want to do it in one way so that it's easy throughout the rest of your code. So you'd create a facade for handling email, and then push that back and connect those two services together with this one facade. So you might have seen this. This is jQuery, actually pulled right from the jQuery source code and then cleaned up a little bit because there's a lot of extra stuff in there. At the very top, you can see document ready. That's what our facade function is. We just use document ready, and then jQuery takes care of binding to any browser event. It's all consolidated to that single method. Again, here are the multiple implementations, and here's that single method, bind ready. All right. So, advantages, we simplify the interface of objects and environments, reduce repeated code, and increased readability. There's a tiny, tiny performance hit for those ifs. It's not worth worrying about, but it is a tiny disadvantage to call out. Any questions on Facade? Okay, next one. Oh, is there one over here I missed? Pardon? Facade? I don't. The question is, what language does the word facade come from? I'm guessing French. French. They say it's French. I'll go with that answer. Sounds good to me. All right, so that's two of our design patterns. All right, our next one is the mediator pattern. So we've got module, facade, and mediator. So a mediator sits between various components and acts as a single place in which message routing changes can be made. So think of this as an air traffic controller. If there are, say there are 50 planes lined up for taking off, 50 planes in the air, all wanting to use the same 5 or 8 runways, whatever there is at this airport. If all of those airplanes are talking directly to each other, there's going to be a lot of cross chatter and a lot of wrecks, a lot of problems. And that's why there's an air traffic control who can take messages from each of those planes. One would say, hey, I'm ready, I'm all prepped for takeoff. Another in the air would say, I'm all ready for landing. And the air traffic controller would say to one for takeoff, okay, you're number 3, or go to runway number 3. And they'd say to the other guy in the air, get into a holding pattern, there are 5 airplanes in front of you, and that kind of thing. So rather than having the cross chatter between all 100 planes, they have one place where they can talk and communicate, and that mediator, the mediator pattern, will respond with what needs to happen or how, what they can do next. Does that make sense? All right, let's take it a little bit away from aircraft controller, go to building an email client. So we're going to build a little email client here. You might be thinking, wait, how many here have built an email client before? Just even a simple one. Got one. Was it easy? A simple one, yeah, right? All right, so reading is pretty simple. If you have to start adding different features, that can be a bit of a challenge. But let's think of it. So let's say we're going to do a simple Gmail-esque reader here. So we've got this viewing pane, we've got an email list, and we've got these boxes. Already we have these different modules up here. We've got the box module, the email list module, and the viewing pane. Well, let's say we get, you might think to yourself that with just 3 modules, airplanes, there's hundreds all around a single airport. With 3 modules, that's not going to be a problem. They can talk to each other. Now watch this. Let's say this is my personal inbox, and I get new email into the inbox. So the box needs to say, hey, email list, there's a new email. The box counts, it's got an email here, email list goes bold, and then it automatically goes into my viewing pane because I wanted, the way I wrote this client, I'm having the viewing pane show the latest email. So the viewing pane says, great, they've scrolled now, let everyone else, let the email list know that I'm done reading, so it can go not bold, and then decrement the count on the boxes. All right, so we've only got 1 interaction here, so that's not too bad yet. This is for a very simple email client. Let's add a couple things. So let's add stars. Let's say we need stars to go back and forth. And then we're going to add some labels. We've got some label ipsum going on. That's how I label my email client. It helps me figure out and categorize everything really well when I get it from my designer. And then we're going to add some due dates. Make sure they're star dates. Those are good ones. And then some unlicensed Disney fan art. So this is my email client that I'm building. Got to make sure it supports the Disney fan art. And when one Disney fan art gets added, or I get an email that has more in it, I've got to show a count on the left. I've got to show it in the middle. I've got to show it on the right. And suddenly, there's crosstalk everywhere in this very simple application. So instead, with a mediator, we just stick an email mediator right in between those, right in the middle of that. And we have everything communicate with the email mediator. And it lets them know when there's a new email client, or a new email coming in. That make sense? Okay, got some nods. All right, so the problem with mediator, objects often need a way of communicating with each other, but direct communication causes tight coupling And many-to-many relationships, like in the airplane example, can be very complicated. So the mediator reduces the number of communication channels between those modules and promotes loose coupling in general. If I wanted to add another component to my email client, I could easily do that and hook it into the email mediator, and it would be notified anytime that there's a change that it cares about. Make a little differentiation here. Anyone heard of the observer pattern? A few. This is a little different than the observer pattern. The observer pattern is crosstalk everyone, where it's a loop of crosstalk basically, where one airplane says, hey, I need to land, and all the other planes hear him, and it comes back to him and says, okay. The air traffic control says, okay, you can land. Whereas mediator is just only what that component cares about. So, hey, I need to land. Okay, 10 minutes and you can land. And then a little later, all right, your turn to land. All right, I'm done with that example. Good enough. A couple examples of those. All right, with these three now in our minds, any questions on those? Okay, dive into the good stuff. Okay, so putting it all together. So with these three patterns, just three patterns, we can build a large-scale application. So let's say your boss comes to you, or your designer, and says, hey, I want you to build this. You say, what is that? I don't like the color everywhere. It's kind of ugly. And then after that, they say, well, do it anyway. You say, okay. You get more definition. You find out this bottom left thing is another email client that we just built. This is a list of people on the right there. And this is a list of a timeline for when you've interacted with someone. And this is profile information. So there's a lot of information there. But it's okay. You got this. Remember, we're going to split this down into small components. We don't want to build a huge application. We want to build a lot of small applications. So, and then I like this quote from Addie. If working on a significantly large application, remember to dedicate sufficient time to planning the underlying architecture. That makes the most sense. Well, with what we've got, we can do this. So I'm going to take away a little color here so it's easier to understand. So remember the email widget we did a little bit ago? That's it, right there. We have a module around this set of modules that we already created. So now we have an email widget module. And we'll just call that the email module. Let's group everything else into their own modules. We've got a timeline module, a header module, a people module, and an other module. I don't know what other is. Maybe it's like latest golf scores or whatever latest tournament is on. Maybe it's, yeah, I don't know, other. I'll have to ask our product guy next time. So there's our module pattern. All these are separated into small groups. How many of you have done this before with an application? It's intuitive, right? It makes sense to kind of split it into small groups. And so now you have a name for it. When you talk with other devs, you've got, you can say, oh yeah, I created this module. And this happens all the time in Angular. Every directive that we create, every service that we create is modularized by way of the framework. The framework helps us modularize that. So anyway, all right, then we say we need the facade pattern because we have some methods that we want to deal with here. Let's say in the email module, we have this get active box and get active email. But it's likely that only the email cares about that though, and not the rest of this application. So in our facade, let's not expose those. We don't care about that in the rest of the application. The facade hides away those different methods so that we don't use them elsewhere. What we might care about elsewhere is a count on the email, and so we expose that through our email module facade. And on the people module, we expose get all people because maybe we need that information at in this timeline area. So we have people talking, communicating with each other. And then we create an app mediator that just communicates with all these different components and lets them update each other. So that's it. In a nutshell, 3 patterns, module, facade, and mediator, and all together can build a large application. So, as Napoleon Bonaparte said, along with our French, software design patterns will help us rule the world, or at least help us communicate with each other. So just as these architectural patterns help us to communicate and build something like this, or this is just a gambrel roof that's extended, or even something like this, simple shed roof, right? These design patterns, and even just the 3 that we had, can help us build something like this. Thanks. Any questions? That was pretty rushed, but some simple design patterns. Was that good? Okay. Awesome. Glad it was good. Here's some resources, briefly. So I have a list of these on my website. I'll turn to that slide in a minute. This JavaScript design patterns by Adi Osmani is my favorite. I haven't read all of these, but I've read pieces of all of them, and I really like this one. If you're really, really into computer science and deep computer science, then that Gang of 4 pattern book that I showed you earlier is great. I've never been able to digest it. I'm not that into computer science, so this one is great for me. And then you can find a link to this talk on my blog. There's not much else there. And then that's it. Thank you all very much. So there's more food in the back. Feel free to go get some. Looks like extra dessert. I'm going to rush over there and get some food for me. And we'll have Danny set up here in a minute.
Test. Okay. All right, so it looks like everybody's about seated. Okay, so I'm Danny Fenstermaker, UI engineer for Jive Communications. We are located in Orem, Linden area. We're a VoIP company doing phone over the internet. We use Angular front end, Java back end. And yeah, so I just want to talk about some of the things we're doing with Google Analytics and Angular. So at Jive, we have a pretty small front-end team, relatively. Many applications and not very much time as is usual. One of the things we're constantly doing is pivoting and having to refocus on the different applications and just trying to get the best results we can in the shortest amount of time. One thing we needed to do is help ourselves figure out strategic points to pivot and focus, and one of the things we used was analytics to do that. So what we needed from analytics was transparency, usage reports, browser support, language support, error reporting, and granular UI component level reporting. So here's our current UI structure. We have a core UI, 2 libraries that supply all of our usable components and architecture, and then a Jive SDK that provides all of our abstractions to the server, API abstractions, so on and so forth. Each of our applications are using these 2 core UI libraries, and we have approximately 8 to 9 plus applications, front-end applications that we are building there. So on the core UI, we're looking to get some analytics on our API abstractions, WebSocket abstractions, and so on and so forth. We wanted to track individual components and API usage, any kind of errors happening in there. Individual apps, we just wanted to track user count, page use, custom component use, so on, typical analytics data. First thing we did is hook up the script that comes with Google Analytics, which was quite underwhelming, not set up for single page applications, not going to give you any kind of click tracking or any of that kind of information. After searching Google a little bit, we came up with AngularJS, which is built specifically for Angular and comes with an awesome abstraction. It allows you to do things, directives on your actual DOM elements there to track clicks and categorize your events and send a description. And then there's also the bottom one there, which is a service that can be injected in any of your JavaScript anywhere or Angular anywhere and do a track from inside the code. I added a small thing there for auto track by Google. Google just came out with this about 2 weeks ago. It's essentially what they're doing with AngularJS, but already built into Google Analytics. So you can throw auto track onto there, and it already takes care of single page application tracking. It gives you the top directive style tracking like AngularJS does, and it's a little bit lighter as far as library size goes. So just hooking up the AngularJS the way you've seen there, we were able to start tracking individual components, clicks inside of those components, start seeing what our users are actually doing in our application. So yeah, like I said, we're able to now see how many users, what they're clicking on, what features are being used, what's not being used, and hopefully use this information to help us focus on where our users are and make that experience better, while also tracking what they're not using and hopefully allow our UX team to focus on those things and figure out what they need to do. So out of the box, AngularJS, we get transparency, usage, browser support, and language support. One thing they didn't think about in AngularJS at all is error reporting or granular level reporting for individual components. So Angular, out of the box, this is a factory that is built into Angular that they're using already. The exception handler essentially does just puts out the actual exception that happened into the console. By creating a factory in Angular and naming it $exception handler, you are essentially hijacking the exception system in Angular, and you can then inject, in this case, I'm injecting AngularJS into there and pushing the actual errors into Google Analytics. In this case, I'm injecting window here, and it's already giving me the exception. I'm injecting window so that I can get the href of every exception that happens, so I know when, what page and state the client was in at that exception time. So right there we get Angular errors and the URL that it happened on. And dirty laundry. You can see here that we're getting a list of Angular errors happening. And for each of those, it's the error that came from Angular dash and then the actual URL that it happened on. And then we can see by date when this gets pushed out to staging. If there's a new push to staging and all of a sudden we're getting a spike in errors, we know that something in that push, we can isolate the issue to that particular push, and then we have the URL which it's happening on, which allows us to quickly get in and see where we need to be dealing with things. Typically, because we have 9 applications, we have few engineers as far as front end goes. We try to focus on errors happening in bulk and not so much one-offs, because we get a lot of those. So we typically 25 or so errors a day. We start looking into it. Yeah, I mean, obviously this is client specific as well. But. So we figured it out for Angular. That takes care of errors for Angular itself, and we're getting everything from there. But we also needed to get the same kind of thing for our other SDK libraries and component libraries and so on. So we basically agreed upon a syntax of the way that these errors and events should be tracked. And then each individual application would create its own Google Analytics property, which is essentially just an application in their system. It would be assigned a tracking code, and then each property would name its tracker. And in our case, we have an abstraction for this, that you just give it the tracking code and the tracker name, and it already knows the syntax or the expected syntax of the errors and events that should be pushed to Google Analytics. And in this case, you just say, create the tracker, and then for every time you send something, you just put the tracker name in front of .send, and it sends it off to Google Analytics. So this is for, we use WebRTC, and this is a just JavaScript library that's being dropped into all of our applications, and we're able to track on this library the amount of WebSocket connections that are happening, the amount that fail, yeah, so on and so forth. We can actually see data within our across all of our applications on a per library basis. So as far as what's next, I'd like to start getting the application names, which you saw there was already a namespace there for it, the version of the library that they're using, and possibly even things like npm package versions of each individual package, so that we can see what all of our engineers are doing with their builds. So alternatively, there is Raygun.io, which does the error tracking as well and gives you a really nice UI and sends you emails if there's particular errors that happen or all errors that happen. It's nice. It's not free, and it's not cheap either. So if that's an option, that would be awesome to use instead. Also, as far as Google Analytics go, Mixpanel is a great alternative there. It allows you to upload anything as far as analytics go. In addition, it allows you to, Google will not allow you to upload user information, and Mixpanel will allow you to do that. And in fact, you can upload any JSON object to Mixpanel for every data point that you want to send up to them. So like I said, if you want to, for us, if we're going to track user information, if we need any kind of specific user information, we're going to hop over to Mixpanel and start using that. If you don't exceed the number of data points per month that they start charging, then it's free to use. And yeah, you can get some pretty vital information for product owners and designers and stuff like that when they need to jump into that kind of information. Something else that we use for information is called OLARC. It's a free embeddable chat library that allows customers to talk directly to someone on the other end. One nice thing about OLARC is that it keeps a log of every chat, and throughout that log, it keeps the URL that the user was on as they're communicating with the person on the other end. And so you can actually go log by log and see where the users are having problems, see what they're talking about and what URL they were on, and just more information at your disposal to figure out your UX issues or problems users are having with the application overall. Additional information, user reports. This is free and embeddable as well, that essentially allows users to report bugs, request features, vote on those features, and for every interaction that the user has, it sends us an email address for them, and if we need to dive into a bug or try to reproduce and we can't, then we can contact the actual user. Just more information at our disposal there. So combining it all, we have a lot of data. We have OLARC logs, user reports, Mixpanel, customer information, Google Analytics. And just with all of that, we have customer feedback and tied data, actual customers' issues being solved and logged, a voting system for feature requests, emails to bug reports, ability to track a user throughout the app by ID. One thing we haven't quite solved yet is what to do with all of this information. As you have 4 applications producing tens of thousands of data points a day, there's definitely a lot of data to go through, and yeah, figuring that part out still. Sorry, this went a lot faster than expected. Yeah, so my name is Danny Fenstermaker, Jive Communications. There's my contact information. Is there any questions that I can answer? So you can create tracker codes if you wanted to. Yeah, otherwise URL. In our case, I just filter by URL and say like, there's a URL, our URL happens to have staging in the URL, so I can just filter any data points by the staging URL. Otherwise, you could create a tracker that is .staging and have that sent up. Since it's free to push data to Google Analytics, like, 50 applications, no limit. It is lossy though, so it's not going to record every single data point. It's pretty good about it though. I think, yeah, you're not going to not see any for the most part. So, anything else? Go ahead. Yeah, so it doesn't show any here because the actual exception is in the front. Yeah, so if you look right there, it says invalid argument. That's the exception that was thrown from Angular. If it was an ng repeat exception, it would be there as well. The other nice thing is that we can see if there's browser-specific exceptions here. So we can say, are we having problems on IE specifically? There's 500 errors a day coming from IE browser. Specifically, we can go in and target IE and just fix it on that browser. So that's another good point of that. Great. That's all the questions? Go ahead. So I haven't tested the size of the string that you could send, but I assume that you could stringify just about anything and push it up to them. I'm not sure the maximum string size that you're allowed to send, though. I've sent some pretty large errors up there, though. ng repeat errors are pretty large in and of themselves, and yeah, it hasn't had any problem with that. And if you stringified a JSON object, you could just JSON parse it in the browser and get all the information back out. So, anything else? Great. Thanks, guys.
Test. I've had people asking me how they can come do a talk, or if they didn't have ideas, what they could do to give a talk. So let me share this with you. If I can get it. Got to be smarter than the machine, right? All right, so if you just go to the Meetup site, right at the top now we have some links that are not there. Wow, where'd they go, dude? They were at the top this morning, I promise. All right. Instead, go to github.com/AngularJSUtah. All one word. github.com/AngularJSUtah. Come to the meetups right here. And this, you can come look at talks that are proposed and vote on them. If there's something you care about hearing more, go just put a thumbs up on that topic. So we'll look at this list real quick. These red ones here are just topic ideas that somebody threw in there. And you can go do the same. And we're looking for speakers for all of these. So Angular 2 style guide, working with dates and time zones in JavaScript, regex, Flexbox, intro to Redux. Actually, we have a Redux talk right here that's accepted for May 10th. So if you're curious what's coming up, or if you want to help and come present at one of these, throw a topic up here. We'd love to have you present. So other than that, thank you for coming. We appreciate you coming. One more big hand of applause for Adobe and for Workfront, our two big sponsors this week. We appreciate them. And feel free to stick around and chat. If you're looking for a job or looking to be hired, come over to this side of the room. Or if you just want to mingle and chat, that's great too. We've got this room for another half hour or so. So thanks again. We appreciate you coming.